Alright, so here's a video on 3.2, which is about the product rule and quotient rule. So these rules are in the book, but I wrote them up here anyway. So for the product rule is very easy to remember. It's for when you're doing the derivative of a function times another function. And the derivative, it has two parts, and basically each part involves taking the derivative of one of the functions and then leaving the other one alone. So here you do the derivative of f and you leave g alone. And then for the other part, you just leave f alone and you do the derivative of g. The quotient rule is a little bit harder to remember. It's the bottom times the derivative of the top minus the top times the derivative of the bottom, and then it's divided by the bottom squared. Let's use these to find some derivatives. So let's find the derivative of this function. So for this, we're going to use the product rule, not the quotient rule, because this is multiplication. It's like this is my f of x and this is my g of x. So for the derivative, there's going to be two parts. One of them is where I take the derivative of this one and I leave this one alone. So the derivative is, so I'll do the derivative of this one, which is 2x plus 3, and then the 7 disappears, right? And then I leave e to the x alone. And then I'm going to add, and now I will do this the other way around. I'll do the derivative of, I leave this one alone and I do the derivative of this one. Of course, when I do the derivative of this one, the derivative is e to the x, so it's almost like I left it alone, but I did the derivative. It's just that the derivative happens to be itself. And maybe, so this is the answer, but maybe it would be nice to simplify it because everything has an e to the x. So if I collect everything, I have an x squared, I have a 3x and a 2x, I have a 3 and a minus 7, so there we go. Okay. So how about this one? This one I would say is naturally the quotient rule. So for the quotient rule, I have f on top and g on bottom. So this is my f and this is my g, and I'm using this formula. So the derivative is, I do the bottom times the derivative of the top. So there's the bottom, and then the derivative of the top would be 2x plus 2 minus, right, because I'm using this formula, minus the top times the derivative of the bottom. So I go the top times the derivative of the bottom, which would be 2x plus 3, and to divide it by x squared plus 3x minus 5 squared, because that's the bottom squared. And you know what? We could simplify this one, but let's just not. We could multiply this out, and we could multiply this out, and collect like terms, and we could square this and do all of that. But this is probably a bit too much. For tests and quizzes, for me, you don't have to simplify your answer too much. Sometimes for the online homework, you'll have to simplify it, but for quizzes and tests, you won't have to simplify it. So we could simplify this, but let's just not. Okay, so let's do some more examples. So there's some on the online homework where you find f prime and f double prime. There's nothing special about finding f double prime. What you do is you start with your original function f, and then you take the derivative, and then you have f prime. And then if you have to find f double prime, then you just take the derivative of that, and that's f double prime. So if you can take derivatives, you can find f double prime. That just means taking a derivative twice. So let's go here for the first derivative. So I would say, well, actually, maybe I'm moving too fast. This is naturally the product rule, because this is multiplication, square root of x times e to the x. And I said I was moving too fast because I would prefer to write this as a power, x to the 1/2 power, because I have a rule to do derivatives of powers. So now let's do f prime of x. So this is the product rule. So I'm going to do the derivative of this one, which is 1/2 x to the minus 1/2, right? Because you subtract 1 from the power, a half minus 1 is minus a half. And now I will leave e to the x alone, like that, plus, and now I'll have a second part where I leave this one alone, and I do the derivative of e to the x, but we've been here before, and we know that the derivative of e to the x is e to the x. Right? Now, let me factor out e to the x. I want to simplify this, especially because I'm about to do the derivative again, because remember I have to do f double prime. So it's nice to clean up my answer if I'm going to have to keep working with it. So what is f double prime? Well, it looks like I'm going to do the product rule again, except it's this function times e to the x. So let's go. This will have two parts. In the first part, I'm doing the derivative of this one, and I can do that. So the derivative of this one would be 1/2, because this 1/2 comes down, then this will be here. And this will now be x to the what? Negative a half minus 1 would be negative 3/2. Okay, so that's the derivative of this. And then I do the derivative of this, which is 1/2 x to the minus 1/2. And then I leave e to the x alone. Okay, so for the big picture, I'm in the middle of doing the product rule, and so far I've done the part where I did the derivative of this and I left this alone. There should be a second part where I leave this alone and I do the derivative of e to the x, which once again is just e to the x. Yeah, and maybe it's not entirely necessary to simplify this, but this is not too hard to simplify. First of all, everything has an e to the x on it, so I'm going to pull that out, and then I'm just going to combine the two things that are in parentheses. The one thing that I think we can make this look nicer is the fact that I have an x to the minus 1/2 here, and I have another one here, and I get to combine those. But first things first, let me go with this. So I see x to the minus 3/2 here. I don't see any other x to the minus 3/2. The x to the minus 3/2 only appears here. So I'll just write it down. This is negative 1/4 x to the minus 3/2. The next power of x is x to the minus 1/2. And remember, I did see two of those. So I have a half plus a half, so that just makes 1 x to the minus 1/2. Other than that, I have this, x to the positive 1/2. And that's it. That's everything. So that's the second derivative. All right, let's do this one. So this is naturally the quotient rule. So f prime of x would be, okay, bottom, it's the bottom times the derivative of the top minus the top times the derivative of the bottom. The derivative of this bottom would just be 1, right? Because the derivative of x is 1 and the derivative of 1 just goes away over the bottom squared. Which would actually be Yeah, so again, I have to find the second derivative. I have to really work with this. So let me clean this up. So on the top, I can factor e to the x out of everything. And then I have x plus 1 minus 1. So it's just going to be x. It's just x e to the x is just the top. On the bottom, I am going to square this out. X squared plus 2x plus 1. Because I'm going to find that I need to work with this when I take the second derivative. The second derivative is going to be a lot messier, and I might not simplify that because I don't have to work with that. That's going to be my final answer, but this one I have to work with. So this is going to get a little bit interesting because to do the derivative of this, I need to use the quotient rule. But then on the top, I have a product of two things. So this is like I'm going to have to use the quotient rule and the product rule in the same problem. So let me take this slow. I'm going to use the formula. The quotient rule is it's the bottom times the derivative of the top. And I'm not even going to worry about what the derivative of the top is right now. I just wrote something here. This literally just means the derivative of the top. I'm not even going to, I don't want to do too many things at once. That's how mistakes get made. So it's just the bottom times the derivative of the top, and then I'm going to say minus the top times the derivative of the bottom. I'm going to do something similar here. I'm not even going to worry about what the derivative of the bottom is. I'm just going to write this, and I'll fill it in later, over the bottom squared. Okay, for my next step, I will fill those things in. So this is x squared plus 2x plus 1. Okay, so what's the derivative of this? This is where we use the product rule. So the derivative of x is 1. So I do the derivative of x and I leave e to the x alone, and then I have a second part where I leave x alone and I do the derivative of e to the x, which is just e to the x. So that's that. This over here is much easier, right? This is just the derivative of polynomial. And this is over this. And like I said, luckily for me and for us, we don't really have to work with this. We can just, unless there's a good reason why we have to simplify our answer, which there really isn't in this case, we can just leave this like this. Okay. So let's find a tangent line. Of course, finding a tangent line is easy if you know how to find derivatives. But I thought I would throw in a problem like this. Of course, yeah, maybe I'll write. We already know that a point that the tangent line goes through is this point. What we would need for the tangent line is the slope, and the slope is going to be the derivative. The derivative is the slope of the tangent line. So f prime of x is, okay, product rule, so I do the derivative of this. This is 2x. I leave e to the x alone, and then I'm going to have another part where I leave this alone, and I do the derivative of e to the x, which is just e to the x. So I'm there. Specifically, I want the tangent line at this point, so I'm going to take this x coordinate and put it in. F prime of 1 would be 2e to the 1 plus 1e to the 1, so 3e. Yeah. So, and I don't always write this formula, I always just use it, but we have some funny looking numbers running around here, so let me be explicit about what I'm doing. I'm like, this is my point x1, y1, and this is my m. So y minus e equals 3e times x minus 1. And let me, so as far as I'm concerned, we can call this our answer, but I understand that on the online homework it often wants you to solve it for y. So let me actually keep moving, and I'll put this in a form that the online homework would accept. I put a box around this because I would accept this on a quiz or a test, but I'm just saying let's put it in a form that the online homework will accept, because I know you need to do that too. I would multiply this out, 3ex minus 3e, and then to solve for y, I'm just going to add e to both sides. So y would be 3ex minus 2e, because I added an e to this side. So the online homework would accept this version. I would accept either one. I'm not too picky, but the online homework wants you to solve for y. Okay,